So this is a concept that appears very often on the SAT in one form or another. So you're going to get some sort of function. So it says it's going to be a quadratic one. And do you know, like, generally what this graph looks like? Is it a happy face or a sad face?
Sad face.
It's a sad face. Why is it a sad face?
Because it's negative.
So, and this is a little confusing, but when there's a negative, it's a sad face. So I actually draw it first because then it helps me visualize the fact that this is a maximum.
Oh yeah.
Right? And my brain always messes with me because it's like, oh, that's negative. It's a lesser thing. No, but that's the maximum value right there. Okay. It says a store manager estimates that if a video game is sold at a price of P dollars, the store will have weekly revenue in dollars of R of P. So what does R of P mean?
The weekly revenue.
Yeah, so R is like the name of the equation, right? The function. And P is what?
The dollars.
Dollars. Okay? And right here at the peak is the maximum revenue. And it could be throwing a ball. Like, how high does the ball go? Shooting a rocket, how high does that rocket go? So, or a diver going off a diving board. That's your max. Okay. Other things, just as a side note, that you'll get with these types of problems is, like, if you graph it, it could be like an equation of a diver, like diving, right?
Mm-hmm.
And it'll say, like, at what time does a diver hit the water? Well, you're going to get like a couple of values, but one value you kind of throw away.
Okay.
Right? So when it says, like, at what time does the diver hit the water? Well, what's the Y value at the water?
The Y value at the water.
Mm-hmm.
Is that the height?
Mm-hmm. What is the height at the water? If this is where the diving platform is right here,
mm-hmm.
What do you think? Well, the water would be right here. So what's the height going to be?
I don't know.
0. See? So this is so for this problem, you can call it H of t, and this is t. So it's the height as a function of time. And this whole entire thing right here, it would be 0 right here, because this is y.
I thought you meant up here, the top.
So the y-intercepts. Sorry, the x-intercepts. The x-intercepts.
Yeah, okay.
The x-intercepts are the time that the diver hits the water, or that the rock hits the ground.
5 seconds.
Yeah, so it'd be 5 seconds. But you're also going to get this one, because a lot of times when you do like these types of problems, right, and you'll get like t plus 3 and t minus 5 equals 0, right? Well, you disregard the one that just doesn't make sense in terms of the word problem.
Mm-hmm.
Even though, like, in math,
it won't be negative.
You can't have negative time, so that one's wrong.
Mm-hmm.
That's the answer. Okay. Let's see how this problem works out. So if I go t squared, let's open it up. So first, outside t squared, refoil it.
Minus 5t.
Minus 5t.
Plus 3t.
Plus 3t.
Minus 15.
Minus 15 equals 0. Okay. And then t squared.
Minus 2t.
Minus 2t.
Minus 15 equals 0.
Minus 15 equals 0. Okay. Okay, so, and the actual function would be written like this. H of t equals, and then you just get rid of this part over here. Mm-hmm. All right, so that's the equation. And then they want to know, like, all right, well, at what time does the diver hit the water?
Uh-huh.
The diver hits the water in 5 seconds. Because when you set it equal to 0, and then you factor it, you get this right here.
Oh.
You with me on that?
Mm-hmm.
The other thing they get asked about the diver problem is, what's the maximum height the diver can get to? Mm-hmm. Which is kind of what they're asking in this problem here. So the maximum height, we'll point to it just like with your finger. Where's the maximum height? Yeah. So the maximum height's right here. Okay, and that height is located where the vertex is located.
Mm-hmm.
Right? So that's the vertex. So do you know how to find the vertex of a like a parabola?
I forgot.
All right, so you need to know this formula. There's actually 2 ways to do it, I guess.
2a would be over.
It is
I don't know.
the equation of the axis of symmetry of this guy right here. is x equals negative b over 2a.
I knew there was a 2 and an a and b in there.
I feel like, and also wait, if you have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b over 2a.
Okay, yeah. I like kind of remember.
Okay, so what you do is, let's just see if my problem is even realistic that I just made up. So, what's our a value? Wait, why did I erase that? We'll just edit that part out. All right. All right, so right here, what's negative b?
2.
Right, because that's negative 2, so negative b is positive 2. All right, over 2 times
1.
1. Okay, so it's 2 over 2, which equals 1. Okay, that means, hey, I'm making a good problem so far. That means that this value right here is 1. So the vertex, so that means that this coordinate...
Wait, which value is 1?
Right here, this is 1. Because that's the x value of the axis of symmetry. So the line that cuts right through the middle of this parabola. And also, this negative b over 2a business has an x equals in front of it. And at the very end, you still have your x equals. You have x equals 1. And that's the equation of this line, actually. Right. So now what you do is, well, if I were to plot, like, put this coordinate in, I know this is 1 comma something. Well, how do you find the something?
You plug in 1 for t in the equation.
Yes. You plug in 1 for t and you'll get your y. And your y is your h of t. So let's do it in fancy math way. So h of 1 equals 1 squared minus 2 times 1 minus 15. H of 1, so the height at 1 second is 1 minus 2 minus 15. 1 minus
17. Negative 16.
Okay. Oh, right.
Yeah, weird. Negative height.
And also the fact that this should have been a negative in the front to begin with, right? Because it's I'm doing it like this. Okay, so we're gonna have to pretend that it's positive 16. That's what I get from making numbers. Sometimes I'll make a problem where, like, it's totally correct. It doesn't happen very often. All right, so positive 16. Bam. So that's the maximum height. So there's only one other thing they can ask. Well, one other thing that you need to know. So just to recap, you have to know the x-intercepts, but you have to know what they mean in terms of a word problem. What does the x-intercept mean in terms of a word problem?
In general?
Yeah, what does it mean, like, in terms of a diver or a rocket?
Like the time.
The time when it what?
Lands.
Yeah, it hits the ground, right? Let's see. And then when you find the vertex, what is that going to give you?
It's going to give you the time of the maximum of the height.
So make sure you're answering the question correctly, because there's 2 questions here, actually. The first question is, what's the maximum height?
16.
And the second question is, at what time does it reach its maximum height?
1 second.
1 second. Okay. The other thing, which is the harder one, is to write this in vertex form. Okay? So you know how you have like an equation of a circle. Like, you can have an equation of a circle that looks like this, like x minus 3 squared plus y plus 2 squared equals 9. Do you know that's a circle? Do you know what else we can tell about the circle? We can tell a couple things about the circle.
I don't remember much about circles.
We know the radius. What's the radius of the circle?
Is it negative 3?
The radius of the circle is, so this value here is r squared.
So it's 3.
So yeah, so the radius is 3. And we also know the center of the circle. So the center of the circle is just opposite sign, comma, opposite sign. So the center of the circle is 3, comma, negative 2.
Oh, I see what you mean.
Okay? But if I were to open this up, and it's a little annoying to do, but you can do it. Open it up. Let's see if you can do it the fast way.
X squared
Okay?
minus 6x plus 9.
Cool. Open up the second one.
Y squared plus 4y equals, or plus 4.
I think you're right with the 4y. 4y. Oh, is that what you're saying?
Did I not say that? Oops.
I think you did. Okay. Equals 9, right? Okay. Now I can go ahead and these guys kind of like wipe each other, don't they?
Mm-hmm.
So then you're gonna get x squared minus 6x plus y squared plus 4y, and I'll move the 4 to the other side just to be annoying. Minus 4. Okay. So here is also the equation of a circle, but it doesn't help.
Yeah.
Why? Because what doesn't, we can't see something right away from it. What can't we see?
The radius.
And we also can't see what else?
The center of the circle.
Mm-hmm. So then we do like all this completing the square business, and we put it in like proper circle forms that we can see stuff. Same thing with quadratics. There's something called vertex form. So you can actually see the vertex right away just from looking at it. And it involves completing the square. Okay, so what you do is you get this guy right here, copy down again. So t squared. Actually, I'll write it like this. Yeah, I'll show you as y. Y, no, but do it the right way. H of t equals t squared minus 2t minus 15. All right, so I'm going to put equals 0 here for now. And let's go ahead and move the 15 over. So plus 15, plus 15. Then we're going to get t squared minus 2t equals 15. Okay. Do you remember how to, and then we still have h of t over here. Do you remember how to complete the square?
Yes.
How do you do that?
It's like half of 2.
Good. And then what do you do with that number?
Square.
You square it. Okay, so t squared minus 2t plus, and it's always positive because you're squaring it. Good. Plus, and then I'll just do the, like, kind of show you what you just did. So you did half of that, then you squared it, right? Do you do something else as well? So you can't just magically throw things in.
Oh, on the other side too, right?
Yeah. So you have to
You have to add 1 on the
if this is our like equation right here, if you put something on one side, you got to also put it on the other side.
Yeah.
Right? So I'll just go plus 2 over 2 squared. Okay. So then we're going to get h of t equals t squared minus 2t plus 1 equals
15 plus 1, 16.
Good. 16. And then we're going to go ahead and, so in this, by the way, is your perfect square.
Uh-huh.
Okay, so it like factors beautifully. All right, so if you were to factor that, what would you get?
T minus 1, t plus 1, t minus 1.
So you do agree that you created, we did complete the square, right?
Mm-hmm.
So numbers that are perfect squares are numbers like 36, 100, 25. Other perfect squares, x plus 2 squared, x minus 3 squared. These are all perfect squares.
T plus 1
I could have rewritten it, and these would have been written as like 10 squared and 5 squared and 6 squared, right? So because we did that, we know it's going to be one of these kind of guys, like this. So just
t plus 1.
Well, you take the square root of the first guy, which gives us what?
T.
You take the square root of the last guy, which gives us what?
1.
You steal this sign right here.
T minus 1 squared.
If you foil that open, you're going to get that. So you don't actually, if you know that little rule, like square root of that, take the first sign, you can jump right to this. Okay? And then so now we have h of t equals that. We'll go like that. Now we can move the 16th over.
To this side?
To this side over here.
So t minus 1 squared minus 16.
Equals t minus 1 squared minus 16. And leave it like that. This is a vertex form.
Okay.
This tells you the location of the vertex without actually having to do that. It's opposite sign, take the sign. So opposite sign here is what?
1.
Take the sign here is what?
What do you mean by take the sign?
Like it's gonna be it's gonna be 1 comma negative 16.
Okay.
Do you understand? Take the sign.
Oh, so like keep it.
Keep it.
Okay.
So, and the reason why it's not doesn't match our diver is because I gave you the wrong problem, right? That's why I just made up that number there, but it actually should have been negative 16.
Uh-huh.
All right, so that's why it's called vertex form. So vertex form is this guy. So it gives the vertex, right? Gives the vertex. And what's the vertex again?
1 comma 6 or negative 16.
Opposite sign, comma 16. Okay. We're gonna do it again. And now we're gonna do it a faster way. So.
The vertex or?
Uh-huh.
Uh-huh.
All right, so we're going to convert this to vertex form. So you know how we move the 15 over there?
Mm-hmm.
We're not going to move it over there. We're just going to realize that we don't touch it. So you're going to go h of t. So we can get rid of this. We don't need this part anymore now. So we're going to go h of t equals, so this part right here, kind of move this guy off to the side over there. Okay? And then we're going to cut this in half, square it, reduce it, gives us what?
1.
Good. We move it to the other side, then we bring it back over here, so it's minus 1.
Okay.
Do you understand that? Because that's what's gonna happen anyway.
Why is it?
See, so we added, where did we add our 1? Yeah, so we added our 1. We created our 1 here, but we can't just magically throw 1s in places, so we put it on the other side. Well, now we're dealing with the same side. So if you bring this 1 back to this side over here, what is it going to be?
Nothing. Well, if you're subtracting it.
So like, you know, like if you have like y equals 3x plus 2, 3x squared plus 2x, and then I go plus 1, and then over here, I magically put in a plus 1, and then over here, I'm like, well, I gotta magically put in, right? But then if you wanted to bring this one over here, what would you do? So isn't that the same thing as 3x squared plus 2x plus 1 minus 1? Which basically means I didn't do anything. Because plus 1 minus 1 is 0, right? Same thing. So we're just going to do plus 1 minus 1.
Okay.
That's our 0.
I see.
Okay. So now, get rid of this right here. So you're going to complete your square with this piece.
Okay.
I mean, you're factoring with this piece here.
So it's still t minus 1 squared.
T minus 1 squared, and then connect this piece right here.
This one.
Minus 16.
Oh.
Right, because 15 minus 1. Okay. So you're going to get h of t equals that. So that's a faster way of doing it.
Okay.
And now we have the vertex. What's the vertex?
It's 1 comma 16.
1 comma negative 16.
But
opposite sign, take the sign. Opposite sign, take the sign. Yeah.
I was just changing it.
Oh, for this problem. Okay. So that's what they want you to do here for this problem. Which of the following is equivalent in forms of RP that shows as constants or coefficients the maximum possible? So shows as constants or coefficients the maximum possible. Okay. So if you were to put this in vertex form, you'd be able to see the maximum, right? All right, so let's put that in vertex form. So RFP equals
negative 4p squared
negative 4p squared
plus 200p plus 100 square.
And wait, let me pause. So what you want to do first is you want your coefficient to be 1. Like when you complete the square, you don't want to complete it with a 4.
Oh.
Okay, so you go negative. So basically factor out the negative 4.
Okay.
Okay, so you
Already?
have, so negative 4, and then parentheses, then what do you have?
P squared.
P squared.
Minus 50.
Minus 50. P, right?
Yeah.
Okay, now we are ready. Okay, now you can do your thing.
Okay. So, negative.
Machine erase. Let me clean this up. Okay, go ahead.
Negative 4. And then in parentheses, p squared minus 50p. And it's 25 squared.
So you kind of,
I
yeah.
don't know what that is.
625.
Yeah,
Okay,
625.
625. Okay, parentheses.
Equal.
And then, so instead of moving it to the other side, because we can't just magically throw in these numbers here.
Yeah.
Okay, now this one's hard because we actually didn't magically throw in a 625.
We didn't?
No, we magically threw in 4 times 625.
Oh, so it's minus.
Quick, let's do math.
Later.
So 625 times 4 is 625. 2500.
Negative.
Yes, because if you have the equal sign, you put it on the other side, but then you're bringing it back, right?
But actually, it's positive, right? Because if that's negative, it's already negative.
So, oh yeah, you're exactly right. You're right. It should be positive.
Positive.
It's because we magically threw in negative 2500.
Mm-hmm.
So then we have to magically throw in negative 2500 here and then bring it back to positive 2500. Awesome. All right, so now we can go ahead and factor this guy. Let's go ahead and perfect square factor this guy, which is an easy factor.
Negative 4p squared plus 200p. Or
No, factor this piece in here. The easy way. Just take the square root, steal the sign, take the square root.
P minus 625.
P,
Yeah.
P minus,
625.
we'll take the square root. So you're going to take this, you're going to go bam,
25.
bam, 25 plus 2500. Hopefully that's the, I didn't even check. Oh, don't forget the square. Okay. So that's our guy. So now we know the maximum. The maximum happens at, wait, what is P? Because P is our X value.
What is P?
So
That's the
where does the maximum, we know like, it says here, you're going to get the maximum revenue at P dollars. Well, I know P dollars. I know what P is going to be to give us our maximum revenue. Just like I know, did I erase the diver? I know how many seconds it is when we get the maximum height of the diver. How many seconds gave us the maximum height of the diver? 1 second.
Because it was the axis.
And then, right. So how many seconds here do I, and here it is right here. Here's your 1. So here, I know what the price is that gives us our maximum revenue. $25 or whatever. And then I actually know what the maximum revenue actually is.
Negative. Oh, wait, no, positive.
Yeah.
25.
Pop the sign, take the sign.
Yeah.
That's it. You're welcome. Stop and save. Okay.